Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to start a new topic of discussion which is signal to noise ratio. In this video, firstly, I will define what is actually signal to noise ratio, and I'm going to explain why this signal to noise ratio is very important for a communication system. For example, signal to noise ratio can determine whether you can or you cannot receive the signal. So basically, these are the objective of this video. Guys, if you're keen to know more about signal to noise ratio, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on signal to noise ratio. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are always welcome to ask me your question through the comment. Before I continue, I'd like to urge you guys to help this channel by like this video. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let's imagine you are employed by a cellular service provider and your key job is to ensure the signal is able to send from transmitter to receiver. So hence, what can you do about this? So in order to ensure the reliability of this communication link, you probably will measure the signal strength. But measuring the signal strength, is it good enough for you to determine whether the signal can send from the transmitter or receiver? So now again, imagine you are in two different classrooms. So for example, I'm teaching in a quiet class. So you can imagine that my signal, which is the S, will be able to reach to all the audience in a quiet so-called classroom. This is because the noise for this classroom is almost zero, which means that they don't add any noise. So therefore, from here, I'm pretty confident that when I actually send a signal up to all the recipients in the class, I'm pretty sure that the signal will be able to reach all of them. On the other hand, imagine in a noisy classroom. So again, you look at this signal to noise ratio. With the same amount of signal, which means that I don't adjust my volume. So now the class may not be able to receive my signal, because of the noise. When the noise of the class become noisy, as you can imagine in a real scenario in a so-called life, so you can hardly hear your teacher. But in a quiet class, you are definitely able to hear your teacher. So basically, this is what it's all about. Whether you can or you cannot receive the signal cannot just depend on the signal itself. You also need to consider the noise. As you can see from here, the signal to noise ratio for a quiet class, you will be able to receive the signal, while the signal to the noise for a noisy class, which make you unable to receive the signal, even though I send the same amount of signal. So basically, in short, when the S over N, we want it to be as big as possible. How you can illustrate over here? Definitely, we want our signal to be as big as possible. And definitely, we want our noise to be as small as possible. So when a big number divided by a small number, which means that my signal to noise ratio as big as possible will be good. But for this particular case, just say that the noise is almost equals to the signal strength, which means that signal to noise ratio is equals to 1. So this make it almost impossible to receive the original signal. So basically this is why signal to noise ratio is very important for a communication system. In short, for a communication system, I cannot just monitor the signal. I also need to consider the noise in order to be confident, to say that I am able to receive this signal. What is actually signal to noise ratio? Let's come to the definition of signal to noise ratio. So this SNR is a measure of the strength of a desired signal relative to the level of background noise, often expressed in decibel. Okay, so this is what I meant earlier on. So signal to noise ratio is actually a ratio, okay, which is signal on top and noise below. Okay, so the signal is actually our desired signal, while the noise, okay, can be the background noise. A high SNR actually indicate a clear signal with less interference from noise, which I have described. So in short, I want my SNR to be as big as possible. When SNR is big, which means that I'm pretty sure, okay, my signal will be able to reach my audience or the receiver. In essential, okay, it actually quantify how much of the desired signal is present as compared to the unwanted noise. Coming to the signal and then the noise and the SNR measurement. Okay, the signal actually refer to the desired information or data being transmitted or processed, while the noise basically encompass any unwanted or interfering signal that can degrade the quality of the desired signal. Okay, the noise can be internal noise and also external noise, which we are going to take a look on my next video. Okay, so my next video, I will concentrate on noise. This video, I quickly explain what is signal to noise ratio. Okay, so how can we actually obtain the signal to noise ratio measurement? Okay, so the SNR is typically calculated as the ratio of the signal power to the noise power. Okay, so basically this is, in short, the definition of signal to noise ratio. Before I continue, guys, again, urge you to help this channel. If you have learned something from this channel, I seek your support to like this video. Okay, when more you guys actually help to like this video will have a better chances to reach up to a larger audience. So guys, help me press the like button now. If you have learned something again, I appreciate that you can support this channel by subscribe to this channel. Please also remember to turn on your notification bell. Once again, thank you so much for strong support. Now quickly understand, okay, why signal to noise ratio is very important, especially for a communication system. Okay, so in the previous comparison, okay, in the class so-called example, you can understand, okay, what is meant by an unwanted signal. Okay, so this unwanted signal, you can also call it a noise. Okay, which means that this is the signal that I don't want to receive. I only want to receive my intent signal. Okay, so anything that I don't intend to receive, I can call it as unwanted signal or noise. Okay, so as you might imagine, okay, it would be nearly impossible to listen to the other party in your conversation under such condition. Okay, remember, under this noisy classroom, okay, where N is also considered quite significant number as compared to the signal. So with this, I am almost not able to listen to anyone that actually talking in the class. Okay, so therefore in this scenario, okay, we will consider signal to noise ratio fall below acceptable parameters. So in short, for SNR, they actually has a criteria which we are going to take a look, okay, in this video. Anything that we fail to so-called receive the signal, we call this SNR below the acceptable parameters. Now, suppose the desired signal contain essential data with strict error tolerance. Okay, sometimes the communication, okay, we want to ensure, okay, so basically zero tolerance, which means that the link must be always established or close to 99.99% established. So in this case here, the receiver task of receiving the desired signal becomes exponentially more challenging. Okay, so in summary, this is why we always want to maintain a high signal to noise ratio. Furthermore, in some cases, okay, this can determine whether a device function at all. Okay, because some device actually need to have so-called the link, okay, some communication link in order to function. Okay, for example, your smartphone, okay, if they don't have cellular, for example, they don't have Wi-Fi, they may not be function at all. Okay, so basically this is what you want to say. So therefore, okay, when they don't have any form of communication link, it may impact the performance between the transmitter and also the receiver. Okay, so let me give you an example, a very simple example to calculate signal to noise ratio. Okay, so if your device radio signal actually receive a signal at minus 65 dBm and the noise floor is 80 dBm. Okay, so from here you can see that my signal is equals to minus 65 dBm while my noise is actually minus 80 dBm. So therefore, okay, when I actually take the signal minus the noise, I actually obtain 15 dB. Minus 65 minus 80, so therefore I actually obtain 15 dB, which means that my signal to noise ratio is equal to 15 dB. Okay, so this means the wireless connection has a signal strength of 15 dB SNR. So therefore, different types of connection actually require different minimum SNR value. For example, if a connection requires 20 dB of SNR, there will be a difference between the actual SNR and the required SNR of 20 dB. For example, for this example, you mentioned that, okay, for example, in order to establish connection, it actually requires a minimum of 20 dB of SNR. And for this example that we calculate 15 dB SNR, which means that it's not enough to guarantee that the signal will be able to send from the transmitter to the receiver. Okay, let's take a look on some of the so-called SNR value. Okay, so from 5 to 10, okay, definitely these are insufficient, okay, to establish a connection, okay, as the noise level is nearly indistinguishable from the desired signal. Okay, so basically, in short, okay, if we have this, which means that the noise is also almost equivalent to the original signal. So therefore, we are not able to distinguish, okay, which is our signal, which is noise. So therefore, under this consideration, okay, definitely, okay, is not acceptable. 10 to 15 dB, okay, the minimum threshold for an unreliable connection. Okay, so when we actually have this SNR from 10 to 15 dB, okay, so basically this is, we call this unreliable connection, okay, which means that the line may drop. Okay, so therefore we need to further enhance the SNR to maybe 15 to 25 dB. Okay, so this is actually considered the minimum acceptable level, okay, for poor connectivity. Okay, so in some place, okay, you are too far away from the transmitter, for example. So therefore, this is actually the minimum acceptable level. Okay, let's say even though we have connectivity, it's still considered as poor connectivity. Okay, so 25 to 40 dB is considered as good. And for critical, okay, connectivity, sometimes we expected to have more than 41 dB. Okay, so basically this is where we classify them as excellent. Okay, for example, a Wi-Fi signal with SNN ratio of 40 dB will deliver better network performance than one with 20 dB. As you can see from here, the signal to noise ratio 40 dB versus 20 dB. Definitely 40 dB is better than 20 dB. If the signal to noise ratio is too low, network performance may degrade, okay, because device struggle to distinguish the desired signal from background noise. Okay, this can lead to packet loss, data retransmission, reduced throughput, and increased latency. Okay, so because of weak SNR, okay, so therefore we can have some undesired effect. For example, we lost the data. Okay, so when we actually lost the data, we need to resend the data. So basically, they take out another additional resource. Okay, so because of this, the throughput actually reduce, and therefore we have longer delay to receive the same information. Okay, so noise actually refer to any unwanted interference that disrupt the signal quality. Okay, so it can come from various sources, including thermal noise, quantum noise, electronic noise, impulse noise, and intermodulation noise. My next video, I'm going to discuss all these noise. Okay, so we also have this environment factor. Okay, for example, temperature and humidity, they can also influence the noise level. So besides, okay, concentrate on the signal strength, we also need to concentrate on the noise. So my next video, I'm going to discuss how can we actually reduce the noise as much as possible. Okay, so SNR is a relative measurement of the ratio of the desired signal S to the noise power M. Okay, so basically this is how we calculate, as I mentioned earlier on, basically it's in a power form. Okay, so basically this will actually show how noisy a signal is. Okay, so for a good communication system, okay, we desire that the SNR to be as high as possible, which I have highlighted many times. If the SNR is very high, then we can distinguish the signal very easily from the noise. A low SNR will means that the noise power is comparable to the signal power, and hence, okay, we conclude that it is very noisy, and even we have some difficulty to clearly receive or obtain the signal. So since this SNR is a very huge number, so therefore it is often expressed in dB. Okay, so basically this is a formula to calculate SNR. So this is we calculate SNR in ratio. Okay, so simply the power, okay, for the receiver, for the signal, sorry, and the power for the noise, you take the ratio, that will give me my SNR. So if we want to express in dB, because all these are in terms of watts, so therefore we do a 10 log base 10. So basically for dB, when it's so-called division, it become minus. So from here, I will be able to calculate my SNR. Next, I just want to do a quick so-called figure to let you imagine, okay, how signal to noise ratio will affect your original signal. So for example, this is the original signal, okay, with no noise added. Okay, so basically this is no noise. Okay, so I want to share with you, for example, at two different signal strength. When the signal strength is 10 microvolt and when the signal strength is 30 microvolt, and the noise is still the same. So from here, you can see that we actually have different SNR. Okay, so basically we take the signal strength. Okay, basically we have the different SNR in dB. Okay, so you can see over here. Okay, so because of weaker signal, so basically the noise become quite dominant in this case here. However, when the signal strength actually increase, you can see that the noise actually drastically reduced. So therefore, from here you can see that definitely, okay, how big the signal is still very crucial. Whether are we able to receive the signal or not. So for this case here, I just consider that the noise is the same. We just change the signal strength. And based on the signal strength, from here you can see that this figure, I'm pretty sure that I'm able to receive the original signal. While this figure, okay, as you can see that although it's still quite almost the same with the output signal with no noise added. However, you can see that the noise actually play a very big part, okay, in this so-called signal here. So therefore, if the voice signal is weak, the noise will be a serious problem as the SNR will be low and we will have difficulty to retrieve back the original signal. With this, I'd like to end my discussion. Okay, please help to like this video and also subscribe to this channel. Once again, guys, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.